Hello everyone, welcome to my YouTube video. Today we will discuss my end semester paper of Introduction to Data Science subject. So our first part of our first question is what is CRISP DM phases? Explain it with the real world example. So problem, reduce customer churn for a telco company. So first is business understanding. Define the goal, reduce churn by 10%. Second is data understanding, collect logs, plot tenure distributions. Third is data preparation, clean null values in usage column. Fourth is modeling, train a decision tree classifier. Fifth is evaluation, check recall metrics to minimize missed churners. Sixth is deployment, integrate model into call center dashboard. So second part of our first question is data types with example. First is structured. First is structured data types organized in row, column, schema, and real world example is Excel sheet, SQL databases. Second is unstructured definition, no predefined model. In unstructured, there is no predefined models. Real world examples are images, emails, audio files. Third is quantitative, numerical, discrete, continuous. In quantitative, we store data in numerical form. So real world example is price like $10.50, age, count. Fourth is categorical data. In categorical data, we stored data in group labels, naming original. So real world examples like gender, rating, high and low. So the first part of our second question is Bayes theorem and its algorithm. Naive classification algorithm assuming features independence. So Bayes theorem is equals to PA by B is equals to PB by A into PA divided by PB, where PA by B is the probability of hypothesis A given data B. So here is the example spam filter. Prior P spam is equals to 0.3, likelihood P word by spam is equals to 0.8, evidence P word is equals to 0.5. So P spam by word is equals to 0.8 into 0.3 divided by 0.5, which is 0.48, means 48%. So our second part of question 2 is distribution comparison. Distribution comparison. So binomial, in binomial fixed n trials outcome is binary. In binomial we get outcome in binary form. Application, coin toss, defective parts count. In normal symmetric bell curves, mean, median, mode. So applications are human, height, IQ scores, errors. In Poisson distribution, event occurs at constant rate independently, calls per hour, emails per day. So question third and question four, data wrangling and cleaning. Question 3, data wrangling. Process of transforming raw data into useful format. Example, parsing a messy date string into standard 2023-011 date object and merging it with sales data. Question 4, error versus missing. Error. Wrong data. Error means when we store wrong data like age is equals to -5, and missing is equals to when we do not store any data, means null data, not a number. Imputation techniques. There are two imputation techniques, mean, median and mode. In mean, median, fill with average, we fill missing value with the average, and in mode we fill missing values with the most frequent values. So question A of question number fifth, feature engineering techniques. So first is one hot encoding categorical. Convert categorical into binary column, red blue into 1 0 and 0 1. Second is standardization continuous, scales data to have mean is equals to 0, standard deviation is equals to 1, formula is equals to z is equals to x minus mu divided by variance. And the third is log transformation, applies log x to reduce skewness in data. Example, income data. So fifth could be evaluation metrics. So metrics accuracy, formula for accuracy is TP plus TN divided by total. Its use case is balanced data sets. So precision metrics, formula of precision metrics is TP divided by TP plus FP. The use case of precision metrics is minimize false positive spam recall. So formula for recall matrix is TP divided by TP plus Fn. Its use case is minimize false negatives. So formula for F1 score matrix 2 into P into R divided by P plus R. Its use case is balance, precision, and recall. So formula for AUROC matrix, area under ROC curve. Overall model ranking 1.0 is best. So part C of question number 5, model distinctions. Parametric, fixed parameters, fast interpretable. Example, linear regression. Non-parametric, flexible, no fixed form, needs more data. Example, decision trees, KNN. The supervised, labeled data, input output. Example, classification. Unsupervised, unlabeled, unlabeled structure. Example, clustering. So semi-supervised, mix of both. So part A of question number 6, handling missing values. There are three approaches of handling missing values. First is deletion. So list-wise, remove entire row. Pair-wise, use available data for specific analysis. Second is imputation. Replace with mean, median, or mode. Simple but can distort variance. Third is prediction model. Use a regression classification model like KNN to predict the missing value based on other features. So part B of question number 6 is logistic regression. A supervised algorithm for binary classification 0 or 1. It is uses the sigmoid function to make prediction to probabilities. So here is the formula. P of y is equals to 1 is equals to 1 divided by 1 plus e to the power minus z. If p is greater than 0.5, then class is equals to 1, and if p is less than 0.5, then class is equals to 0. So here is the calculation example. Hello? Input z is equals to 0, decision boundary. Hello? P is equals to 1 plus P is equals to 1 divided by 1 plus e to the power 0. P is equals to 1 divided by 1 plus 1. E to the power 0 means 1, and P is equals to 0.5 means 50% probability. So part A of our question number 7, K-means algorithm. So steps of K-means algorithm is choose K number of clusters, initialize K centroids randomly. Third is assign each point to the nearest centroid. Fourth is recalculate centroid mean of points. Fifth is repeat until centroid stops changing. So here is the process how we calculate centroid selection. So initial selection is critical. Poor random initialization can lead to the algorithm getting stuck in a local optimization. The solution is use k-means plus initialization. So B part of question number 7 is KNN classification examples. So dataset point A11 to class 0 and point B 44 to class 1. Query point X33 find class K is equals to 1. So equivalent distance is equals to under root x2 minus x1 का whole square plus y2 minus y1 का whole square. So distance x a is equals to under root 3 minus 1 का whole square plus 3 minus 1 to the whole square is equals to 2.82, and distinct SB is equals to under root 3 minus 4 to the whole square plus 3 minus 4 whole square, which is equals to 1.41. So result B is closer. X belongs to class 1. So here is the A part of our question 8. So DT versus random forest versus boostings. So features, types. In decision tree there are single model. In random forest there are assemble. In boosting in ensemble. In variance, high. In random forest low and boosting low. So speed is fast in decision tree, moderate in random forest, and slow in boosting. So interpret, high in decision tree, low in random forest, and also low in boosting. So part B of question number 8, logic gates. So there are three gates: AND gate, OR gate, and NOT gate. So there are one neurons in there, and back probe. There is no back probe on all these three. Now the A section of our question number 9, information gain calculation. So goal, select the root node for the decision tree. So global entropy 9 yes 5 no is equals to 0.940. First is gain, age is equals to 0.246 maximum. Gain student is equals to 0.151. gain credit is equals to 0.048 and gain income is equal to 0.029. So conclusion is age is the highest information gain, so it is the best first split. So here is the B section of our question number 9. Gain index calculation. Goal: minimize Gini impurity. So formula for it: Gini is equals to 1 minus summation of P square. So Gini age is equal to 0.343, lowest impurity. Gini student is equal to 0.367. Gini credit is equal to 0.428. Gini income is equal to 0.441. So conclusion is age is also the best split using Gini index. So C part for question number 9 is InfoGain versus Gini index tree. So InfoGain tree uses entropy algorithm biased toward attributes with many distinct values. Result: root is age. So Gini index tree uses probability square computation faster and result root is age. So final runs, both methods produce the exact same decision tree for this data set. Thank you for watching this video.